Hello, in this video we are going to continue looking at Pythagoras' theorem and a little bit more tricky problems where we might have to draw a diagram from a word problem. Okay, so first one we didn't get to do in the last video, but it's an isosceles triangle problem, okay? Let's have a think. So first thing is to label our diagram, okay? We've got a right angled triangle, 3 side lengths involved. It means Pythagoras. So we've got C is opposite our right angle. Our hypotenuse is opposite our right angle. And the other sides are A and B. So label your diagram, then your formula. C squared equals A squared plus B squared. And then we substitute. So C is 4.2. A is X. Make sure you put those squared signs in. Plus B, which is also X. So a lot of students at this stage don't know where to go from here. But the key is simplify. Simplify on each side at every step. How do you reckon we could simplify X squared plus X squared? Now, there is invisible ones here. What do you think 1x squared plus 1x squared is going to be? It's going to be 2x squared. Okay, that's just collecting like terms when you're adding algebraic things, okay? So it's 2x squared. And then simplify on the left-hand side, 4.2 squared. Sorry, something in my eye. 17.64. And then at this step, what do? We want X on its own. And it has a squared symbol hugging it, and it's got the 2 out the front there. Now, what you got to do is there's a little invisible multiply sign here. You're going to remove this 2 out the front first by doing the opposite of multiplying by 2. The opposite of multiplying by 2 is dividing by 2. And what you do to one side, you do to the other. Okay, don't get rid of that squared first. You got to get rid of that 2. The square is hugging it right up close there, okay? So that means you remove it last, okay? Now, so I'm left with x squared on this side. Give me my blue back. Did that select? I'm left with x squared on that side. And 17.64 on 2, divide 2 is 8.82. But I want x, and I've got x squared. Opposite of squaring something is square root. What you do to one side, you do to the other. So we're left with x, and it says corrected 2 decimal places. And so 2.97. is what that answer will be. So this is the isosceles triangle problem. Collect like terms, and there are invisible ones, okay? So keep that in your mind. Problem solving process. Okay, we're going to look at some worded problems, and this is the process we're going to follow. Dr. Whack, okay? Keep this in your mind. So it stands for diagram, rule, working, answer, check. This is what I always check off in my mind when I'm doing problems, okay? Particularly this bit. Rule, working, answer, okay? But yeah. So you might want to pause the video and just have a read of this. What is Dr. Whack? Okay, diagram, you want to label your variables. Rule, check your formula sheet. Working, these are important. Substitute, simplify, rearrange. Answer, so only then do you reach for your calculator, and then 2 things to check at the end, units and decimal places. Here we go. We got our Dr. Whack process down here to help us. So it says a hot air balloon is at a height of 130 meters above the ground. Maybe I'll highlight as we go. It's at a height, so a balloon, height of 130 meters, and a horizontal distance of 300 meters from a dog on the ground. Find the direct distance in meters of the balloon from the dog. Okay, might sound confusing now, but we can do this, all right? We picture it, okay? There's a hot air balloon here. That's not very good, is it? That will have to do. Okay, there's a hot air balloon and it's at a height. Let me just move that. It's at a height. Height means vertical. 130 meters above the ground, and a horizontal, so we've used that bit of information, a horizontal distance, horizontal, so it's important you know what vertical and horizontal is. Vertical means cliff face, horizontal means horizon. Distance of 300 meters from a dog on the ground. Here's our dog. Not very good, we'll have to do. More like a cat. 300 meters from a dog on the ground. Find the direct distance of the balloon from the dog. So just draw them, and it conveniently happens to be a right-angled triangle, doesn't it? Okay. So we need to find this direct distance. Let's call it x. Okay. So we've got our diagram labeled nicely. Now we're looking at what rule could I use to solve for x here? Well, I got 3 side lengths. Information about 3 side lengths in a right angled triangle, that means Pythagoras. And then you're going to make sure you label your diagram with these variables, okay? So hypotenuse, opposite the right angle, hypotenuse is x. And the shorter sides are A and B. Let me move that up a bit. Then you are going to show your working. Now, working is where you substitute and you simplify. You might need to rearrange, but yeah. So we're going to substitute. C, well, that's x. Don't forget your squared. A squared, so 130 squared plus 300 squared. And let's simplify. I'm just going to simplify all in one step in my calculator. I'm typing it all in. 130 squared plus 300 squared. 106,900. We have x squared. We want x. Opposite of square is square root. Do that to both sides. Square root 106,900. And direct distance in meters. And I forgot to say 2 decimal places. So this, let's see what this would. So we plugged in meters. We should get out meters. This is what answer I get in my calculator. So if I'm doing to 2 decimal places, that means this digit means we round up. So it should be 326.96. So always check those 2 things at the end, your units and your decimal places, because you can lose marks pretty easily. Okay, another word problem. A 4.5, let me get my highlighter. A 4.5 meter ladder leans against a wall. If the wall is 210 centimeters high, how high is the top of the ladder from the ground? Okay, to 1 decimal place. All right, now let's draw this. Let's translate these words into maths, okay? A 4.5 meter ladder leans against a wall. Picture that, okay? A ladder, you can label it if you want, leans against a wall. A wall is vertical, usually. We'd hope so. So this is our wall. You can label it with words. And we know that our ladder is 4.5 meters long. If the wall is 210 centimeters high, okay, this is the wall, we labeled it. How high is the top of the ladder from the ground? Okay, let me have a think about this. How high is the top of the ladder? Oh, I think I meant how high How far is the ladder from the base of the wall? So sorry. I'm not redoing this video. How far is the ladder from base of wall? So that is my bad. That's our real question. How far from the base of the wall? Happens to be a right-angled triangle. Now looking at this sorry for this dodginess, but just going to have to do. Looking at this diagram, let me really rule that out. We've got our diagram labeled, but I can see that there's inconsistent units. So you really want to make sure they're the same before you start doing your working, okay? Now I'm going to just choose to work in meters. So centimeters to meters, I'm going to divide by 100. 2.1 meters, okay? So then you look at your rule. C squared is A squared plus B squared. And then we're going to go back to that diagram. We're going to label it with these variables. So C is that, A is that, B is that. And then we're going to working. So substitute and simplify. Substitute. So C is 4.5. Let me get rid of that. 4.5 squared. We got 2.1 squared plus x squared. And what do we do? So we've substituted. Now we're going to simplify. We're just going to do those indices. So simplify on each side. 4.5 squared is 20.25. 2.1 squared is 4.41 plus x squared. Now, we want x on its own. There's some things happening to it. We've got this squared and we've got this one being added. We want to move that plus 4.41 because it's furthest away on this side. So you remove what's furthest first. So I'm going to take 4.41 from both sides. The opposite of plus is subtract. That. And you're left with x squared. 20.25 take 4.41 is 15.84. But I've got x squared. I need to do the opposite. So square root both sides. Cancels that square root sign. Root 15.84. 3.98 if we were to do to two decimal places. And remember, check two things at the end. Decimal places and the units. Oh, whoops, it says to one decimal place. So that's actually going to round up to 4.0. And the units we plugged in meters, we should get out meters. Okay, so that's how far the ladder is from the base of the wall. Okay, next question I think we will do in the next video. Okay, so go and take a break and I'll see you in the next video, okay?